we hear this often. I hear it all the time. From what I know, everybody's come across this. When faced with the question of evolution, a lot of people say that it's just a theory. And can you explain that, Mr. A, about what exactly they mean by that, and what is a theory in science?
This is a mix between the cultural colloquialisms and the way we talk to each other and what is science, and they're very different things. In the colloquial term, theory can mean an idea, a hunch, a feeling, any of those things. And you'll see this not just in a sense across this campus and across your lives, in your households. You'll see this in the media, and you'll see this many times by supposed informed individuals. They'll say theory, and they'll throw it around all over the place. And the reality is that in science, theory means something very different than what they're saying. Science and theory is not just an idea that popped in your head. Science with theory, what we're looking at is a hypothesis, and you generate what's called the research and the null. The research says this if A is related to B, and the null is this is A if A is related not to B or not related to B. So you set up, in a sense, the opposite. This is not something you do in a formalized way when you're thinking of ideas in your head. The next step, even more important, you go and collect data. And when you collect the data, you do it in a very standardized method that can be duplicated by anyone. You make sure that you're gathering up, quote, the relevant variables and so forth. So it takes an intense amount of concentration to do this right, to set this up correctly. And then, of course, you do your testing, your statistical testing, which is not, people don't do statistical testing to figure out if they should go to this restaurant or that restaurant. I mean, they might, but they might not eat either, So there's certain mundane choices we make, which I like to put in the very vague category of informal science, which we make these problem-solving choices throughout our lives, and this is part of the human condition. But formal science in the last 40 years is very unique and different in that way. Because of the hypothesis, the way we collect the operations, the data we collect, and then the testing. And once that's done, then you have the possibility of verification. Not proving, but verification. We don't like to use proven science because it has this air of absolute. There's no absolute in science. Science is uniquely humble. We continually bring in more and more information. This can be through different variables we miss. This can be through new technology that we have now that we didn't have before. And this could be just in the way of unique brains. It could be one of you guys in here that goes on into some field in science. And because of the way you see things, you ask questions nobody else asks. So there's all these kind of variables out there in how this is done. And when we finish off with our theory, we get to the end of the theory, we crunch our data and all that. This is a hypothesis that's been tested, verified, and now we've generated what we call facts, which we build upon. If those theories can be encapsulated into a larger overarching theory like evolution, you could term evolution as a law, and the theories like natural selection, sexual selection, gene drift, mutation, and down the line, those would all go into evolution as a law. You could also call evolution a theory. The same law or theory doesn't necessarily mean one better than the same thing in science's eyes in most cases. We just conveniently try to think of law when something is put inside something else. Now, one small exception. If you do a test and you do the first test, or there's a handful of tests on a particular study, and you get what we call you get your results, and your results turn out to be, after further testing, very aberrant, anomalous, and strange, what you're seeing is you're sampling chance and you're sampling something outside of what's really happening most of the time. It doesn't mean it's not happening, but it means that it happens some of the time. So we have exception, and every rule, in a sense, has its exception. And another thing people miss in science, they try to prosecute science like it's a legal situation where we just need to have that one place. Well, saying that there is, as one of the lab experiments that we do, that there is a no correlation between sex and center of gravity, I can, and I have done this, in certain situations with certain labs, found this, where it doesn't correlate. And so, therefore, the conclusion would be, well, aha, then there is no theory of this. Well, the fact is that in almost all of the, should say, tests of this, it comes forward. So when it's accepted, doesn't mean the other doesn't exist. And this is the kind of game we see that religious fundamentalists try to play. They find the one thing. You find one thing, every theory. Gravity has exceptions, and physicists are dealing with these things, and they're examining these things. It doesn't mean gravity doesn't work. And these are kind of misnomers where we get confused as to how these things work, and finding the one thing doesn't make it disavowed. This is just a lack of knowledge of science and statistics. That's pretty basic, you know.
Let me just add, I don't want to linger too much on this particular question. Stephen Jay Gould, the great paleontologist who died a few years back, used to distinguish in his public lectures and debates with creationists who called themselves creationists at the time. One of whom I had the privilege of saying in my parents' church in Hemet at Dwayne Gish. We used to have the Creation Institute, I think, out of San Diego. So Gould used to, and I think Kenneth Miller, another contemporary biologist, sometimes debates intelligent design people. But Gould's distinction, which may not quite correspond to what you're talking about, but for simplicity's sake, evolution is a fact in the sense of fossil evidence, genetic mutations, the fact that we have to get new flu vaccines every year because the virus has mutated. So there's the factual physical evidence, and then there's the theoretical explanation that best fits that evidence. And there Darwin obviously is wrong in some of the details, if not major details. He didn't have any account of the genetic aspect of transmission of traits. That was going on in the 19th century. Gregor Mendel was actually a monk who was doing experiments with peas, and Darwin was unaware of Mendel's work. So there's a neo-Darwinian synthesis in the 20th century, and subsequently it's wrong to call it Darwinism, which sometimes people do, because it's not about Darwin. We're celebrating Darwin's contribution, but evolutionary biology has made as much progress as anything in physics, so we don't call it, I mean, we do call it Newtonian physics, Einsteinian physics, but physics is physics. Evolutionary biology makes progress and should be humble that a lot of the received conclusions at any given time can be challenged, but that's in the spirit of science. And at that level, I don't think it conflicts with religious perspective at all. I guess we'll get to that. So I would say evolution is a fact, and then the explanation that best fits that fact is natural selection or variations on that, and progress is made in improving theories.